our objective is to introduce the basic shapes of statistical distributions. When we look at this is going to help us understand when we look at data sets where the common and uncommon values are. So first of all, what a distribution is, it's a function or graph that shows which values are common or uncommon. Now, if you look at this distribution, this is called a symmetric distribution here, all three of these. Notice that this shows you that the very common ones are in the middle, and in the red graph here, the middle one, it's called a narrow distribution because they're all kind of bunched around that common value, whereas the broad distribution, some of the uncommon values start sneaking out to the sides, and you have more spread to it. So the characteristics of a distribution that we're going to look at are going to be, we're going to look at the shape, the center, which will give us the location of where the graph is, the spread, and the outliers. So here, the location is right here where the mean is of the graph. The spread tells us how wide it is. It's getting broader, these other ones. The shape is a symmetric or a bell shape to it. And then the outliers, these outliers aren't very far away from the mean. These are a lot further from the mean. Okay, so location and spread will help us define where the graph is. Usually when we look at location, we look at either the mean, median, or mode. Those are the three things we typically use for location. And with spread, there are many different things we could describe spread, but we're going to introduce in the next few lessons, we'll introduce the idea of what's called a standard deviation. That'll be one form of spread, and then the other one will be that we'll use for much of what we use is the interquartile range. That'll help us understand how wide or how spread out this data is. All right, so we're going to look at skewed data and symmetric data. Our skewed data, what you'll do is you'll see with these, the skewed data will have a tail to it. So for instance, a right skewed has a right tail on it. So it tends to have a tail out here. So I'm going to put up here, the way to remember right skewed is it means that it's right tailed. So this number here, this is the mode. This is right where the middle of that graph, the highest point of that graph is the most values. And then usually the median comes in, it's pulled over to the right because it's skewed right. So the median's over here toward the right side. And then the mean gets pulled way over because there's some outliers out here, the values that are pulling the mean to the right. So when we measure this, the measure of center that we usually use with this is usually we use the median. So this one here will help us know where the graph is pulled one way or the other. And then the measure of spread that we'll use is interquartile range. Now a symmetric graph is a graph that we have like up here, it looks more bell-shaped. So when it goes up and it comes down, the tails on both sides look very similar to each other. So it's symmetric because it has the same look on both sides of the middle. So symmetric would have the mean, median, and mode usually right in the same spots. Mean, median, and mode. Right there, helping us to understand where the location is. So we'll use as our center then the mean for it. That gives us our location. And we're going to introduce, as we go, a new thing called the standard deviation. All right, so the last one's going to be left skewed for us. And left skewed is where you have a left tail. So it starts low here, but has some outlying values up here, and then it has values over here. So again, a lot of times people will think this is because the hill in the graph is on the right side, they'll think that's right skewed. It's where the tail is. So we think of left skewed as left tailed. That's where the tail is on the left side. And so for the same thing here, this is going to be the mode. The most is the highest point on the graph. And then we're going to have the median pulled over to the side over here toward the left side. And then the mean gets pulled quite a bit because of these outliers on the side. All right, so we're going to use the same as we did for the right skewed here. We're going to use for the measure of center the median. And then for the measure of spread, we're going to use the interquartile range. To help us understand how wide it gets because of the data. All right, so that's the basic shapes of the graphs. So we need to recall those and use those, and then understand how to place them where the center is, and also how the spread is. Now we want to determine which one. Sometimes we don't know which one is it going to be. Is it going to be left skewed, right skewed, or symmetric? We don't know. The way to determine that, if you don't know, is to create a histogram to see what shape it is. So determine which measures to use by creating a histogram. To find the shape. Okay, that will help you see, is it left skewed, is it right skewed, or is it have a symmetric look to it? So when it's skewed, remember when we have a skewed graph, we're going to use the median and the interquartile range to describe the graph. And if, on the other hand, it's symmetric, where you've got that bell shape to it, you're going to you're going to be able to use instead for this, you're going to use the standard deviation. Now, one of the distributions that we have that is we use the most is the normal distribution. It is a symmetric distribution. So its shape, it's symmetric. So its shape will look like a bell shape like this. Is oftentimes how it's referred to. So the measure of center that we use, again, since we use here the mean for it, we're going to now start talking about whether we use the population mean or the sample mean. And we list them with different different characters to do that. Population mean, what we usually use for that is a Greek letter mu. Okay, so I'll put in parentheses here that's the Greek letter mu. So when you see the Greek letter mu, that means it's for the entire population. It is the parameter for the population. That is the mean. Whereas the sample mean, which would be a statistic, what we use for that is we usually use X bar for this one. So I'll put this here. It's referred to with that little bar on top. It's referred to as X bar. So when you see this X with a bar above it, it's the mean, but it's the sample mean, so it is a statistic, whereas this is the parameter for the entire population. Now, if we're doing the measure of spread, which is the standard deviation, we'll introduce how to calculate this and things like that later. But the standard deviation, that population, the population standard deviation, which would mean it's a parameter for it, the Greek letter we use for it is a little sigma. So it's like a little circle with a dash off the top. That's the Greek letter sigma. And if we're doing the sample standard deviation, which would be a statistic because it's from a sample, that how we'll list that one is we'll use S. Sigma is actually the Greek letter for S, so we'll use an S with a little X below it. So as a subscript, S sub X will be our sample standard deviation. So make sure you know the difference between the parameter and the statistic for both of these. So usually when we do a sample, we'll come up with the sample mean X bar and the sample standard deviation S sub X as what we get for that. So now what we have is we have the basic shapes of all these graphs. The shapes are usually broken into skewed, the left skewed, left-tailed, right skewed, right-tailed, or we have the symmetric graphs. The typical symmetric graph that we will be dealing with quite a bit is called the normal distribution. And with the normal distribution, we have some certain notation that we use when dealing with its parameters and also with its statistics. Let's now actually do an example on our calculator to find some of these data points from some type of a sample. So this is just some random numbers to come up with it. So we're going to do this example, but let's first of all, the steps you use on your calculator. When you pull up your calculator, you're going to be using this stat key quite a bit. So this stat key is kind of the center of what we use for this. So the first thing we'll do is we'll be hitting the stat button and then going to edit and editing a list. So stat and then edit, it brings you to the list. So let me go ahead and show you what those keys look like. So to enter a list, you first of all go to stat, and then you go to over to where it says edit. So we're going to edit a list. So let me pull that up again just to practice it one more time. So we're going to go to stat, and then we're going to do edit, and we have our lists there. Now, the next thing you're going to do is you're going to enter numbers when we do this into a list. So, so here you're going to enter the numbers into the list. And I'm going to put in L1. Usually we'll just use the first one. You can actually use any one of them. Next, to calculate, you'll follow these steps. You'll go to stat. Again, you'll go to calculate. This will be after you get to the home screen. And then you'll go to one variable stats. So one var stats. Okay, and then lastly, you're going to hit calculate when you get to that. Okay, so one variable stats, you're going to calculate. Now let's go ahead and take a look at what that would look like on our calculator. So here's our calculator. So we're going to put into this list the numbers that you've got listed there. So I'm going to put in 16, I'm going to hit enter. I'm going to put in 17, enter, another 16, enter, 15, enter, and then a 17. And then enter. Make sure you hit that last enter to make sure it knows to take that one as part of it. Now, once you've got that in a list, we get out of that. We'll go back to the typical screen. We're going to hit Stat. We're going to go to Calculate. Okay, so over to Calculate. We want to do one variable stats for these calculations, so hit Enter. and then we're going to go down and hit calculate. Okay, so notice you could change the list that you're working with. I'm going to leave it at L1. That gives me a list. Notice it has X bar here. X bar is our statistic for the mean out of that sample. And then notice down here it has SX equals 0.83, etc. There's my standard deviation. So I can pull those values off of this. So I get from it that X bar is equal to 16.2. And I get my SX, my standard deviation for the sample, is about 0.84. So using your calculator, you can come up with some of these measures of what the location is, the center, the mean of the sample, and then also the measure of spread, which in this case is the standard deviation from the sample.